I'm going to give you a categorical syllogism, and I want you to determine whether it's valid or invalid using a Venn diagram. And I'm going to be upfront with you. You're going to run into a problem when you create your Venn diagram, but there's a really simple, intuitive solution to this problem you're going to encounter, and I want you to see if you can figure out what that solution is before I just hand it over to you. So here's your syllogism. Every ghost pepper is a spicy food. Some baby foods are spicy. Therefore, there are some baby foods that are ghost peppers. Now, obviously, this categorical syllogism is not expressed in standard form, so the very first thing you're going to have to do is translate each one of these statements into standard form categorical statements, and then you're going to work through that process that we went over in an earlier lecture for creating a Venn diagram for this particular argument. And when you have completed your work, go ahead and restart your video, and we'll check to see how you did. Okay. So first things first, we've got to translate this into standard form. One way to do that is like this. All ghost peppers are spicy foods. Some baby foods are spicy foods. Therefore, some baby foods are ghost peppers. You may have written yours slightly different. You just want to make sure that you have 3 terms that appear 2 times each, the exact same way both times, and that all 3 of your terms are plural nouns or noun phrases. Then we can move on to the next step, the all-important step of symbolizing this argument. I assigned G to represent ghost peppers, S to represent spicy foods, and B to represent baby foods. That gives us all G or S, some B or S, therefore some B or G, and I am ready to Venn diagram away. Now, because I have a particular premise, I have to begin with the first premise when I diagram. I have to mark the universal premise first, and that says all G are S. So I'm going to come down here to my G circle, and I'm going to darken, shade, turn out the lights in any area of the G circle that's not also included up here in the S circle, and that's areas 6 and 7. So I'm going to turn out the lights in areas 6 and 7 because I want all of the G's that exist to be crammed up there into this S circle in areas 3 and 4. And now I get to move on and diagram my second premise, some B are S. And here's where I run into a problem, right? Because I could mark an X in area 2. If I mark my X in area 2, I am showing the statement some B or S. But I could also mark an X in area 3 to show that some B or S. Both of those X's show the statement some B or S, and neither one of these X's is more of a B or more of an S than the other. Just because this X in area 3 is also included in the G circle doesn't make it less of a baby food. It's still a baby food. It's still part of the B circle, and it's still part of the spicy food circle, the S circle. So, and I only get 1 X for a particular premise. So one solution is not to write 2 X's here. So if that was the solution you came up with, it's a no-go. So we can't mark 2 X's. We get 1 X per particular premise. So when you have 2 potential areas where you could mark an X to reflect a premise, where do you put the X? If you said on the line or the arc separating those 2 areas, you are a genius. The X on that arc says this. It says there's an X in either area 2 or area 3, maybe both. I just don't know. I don't know where to mark this X. Okay? If it turns out we get more information, it's like, oh, there's an X that's in area 3. That's where this X really belongs, then great. Now the Venn diagram shows that this argument is valid, because if there were an X in area 3, there would be some B that are G. It would be right there in area 4 or area 3. But if we get more information, it turns out that X does not go in area 3. It actually falls in area 2. Now the conclusion of this argument, some B or G, is not reflected by the Venn diagram. It would be a false statement. Some B or G. It would say that some B are not G if the X falls in 2. And what that tells us is that when we assume the premises to be true, we don't know whether or not the conclusion has to also be true. It could be false. And if it could be false when we assume the premises are true, that's an invalid argument. Any argument where the X falls on the arc between 2 areas is an invalid argument. And we can verify this by checking this form of argument in our inventory of forms. This is an AII in figure 2. And when we look at our unconditionally valid forms under figure 2, AII does not show up as a valid mood, as a valid form of argument in figure 2. That tells us that this is definitely an invalid argument.